So the easiest thing to do, again, is put it in our calculator and look at the graph. The graph will give us some information. Also will give us the zeros, what we're looking for. All right, so go to our y equals whenever we graph something, right? I didn't want to do that. Sorry about that. All right, so x to the third. How many zeros am I expecting since it's x to the third? 3. You okay, Naomi?
Yeah,
and Carly? Your phone is?
Yeah.
Are you trying to graph it on your phone?
Yeah, I was trying to get to my calculator.
Okay. That's what you should be doing. All right. So put it in your calculator. First thing to do is make sure you put it in right. And I believe I did. All right. So remember, when I'm looking at the graph, okay, let's go over what we see. It goes straight through sometimes, which means how many zeros at that spot? 1. Sometimes it'll bounce off the 0. What's that going to mean? At least 2, right? Even number. Sometimes it bends as it crosses. What's that tell you? At least 3, right? Okay. So let's see what it does. And all we see is it go through once. Okay. Try to make it a little bigger for you. Okay. So it's only going to showing us 1, the one right here. That looks like 1, 2, 3, 4, 5. And I believe that's right. How do I make sure? Go to your table quick, right? Second graph or table. Yeah. And if you look at the 5, there's a 0 here, right? 0 for our y's. So what can I do to try to find the ones I can't see? If I can't see them, then the other 2 are what type? If I can't see them, I got the eyes with them. Imaginary. Okay? So the other 2 are imaginary. So to find the other 2, I have to use what to simplify this? Use 5 synthetic division, yes. All right, so I have 1 for the x cubed, negative 13, 65, and negative 125. Okay, I didn't have to add any zeros. Drop your 1. 5 times 1, and add those. 5 times negative 8, and add those. And 5 times 25 is 125. So there's my 0, which I was expecting, right? Because that's what the calculator told me. All right. Now, this started out as x cubed here, this first x. So this one is x squared, and this is an x. You put the plus because it was positive. So there's my equation I have to solve. Okay? That quadratic. Well, that won't factor. There's no factors of 25 that add up to negative 8. Because, again, we know it's going to be imaginary because we can't see them on the graph, right? So I have to use the quadratic formula here to find the other 2. Okay? So I'm going to go x equals negative b. What's b? Negative 8 plus or minus square root of b squared minus 4 times a times c over 2 times a. Again, nothing new for you guys. You guys have done that many times. Okay, and we're just going to finish simplifying this. And you know, underneath the radical sign, since it's going to be an imaginary answer, yeah, imaginary answer, okay, I got to get a negative underneath the radical, which is going to happen, watch. So I get positive 8 plus or minus the square root of something over 2. So the negative 8 times negative 8 is 64. Negative 4 times 1 is negative 4 times 25 is negative 100. Okay? So what's that, 36? Yeah, negative 36, all right, sorry. Okay, so that works out a little bit nicer because 36, what type of number? Perfect square, right? So that's 8 plus or minus. Take the I out since it's negative, take the 6 out, perfect square. And then we can divide those by 2, so 4 plus or minus 3i. So there's my other two zeros. 4 plus 3i, 4 minus 3i, and the 5. Those are the three zeros for that problem. Okay. I don't know, up to this point, if we had any imaginary zeros when we actually did a problem. I think our homework we did Monday had all real zeros. Okay. Questions on that? So use our calculator to find our zeros. Okay. Whatever the degree is of the problem, this one was a degree of 3, there should be 3 zeros. If you can't see all of them on your graph with your calculator, then you're going to run into some imaginary ones like we just did. Okay? Any questions? Okay. What do we do next? 6? Oh, you have a question. Well, it's my turn to ask questions, right? All right. Make sure you're left. Yeah, you're left. Well, no. You're looking for this one here. You're on the right now. Yeah. All right. Hunter, what was number 6 so I don't have to keep looking?
X to the 4 minus 4x cubed plus 53x squared minus 196x plus 196.
Thank you. So this one,
You got the x.
this one's good. We're expecting how many zeros this time? 4. The exponent of the first one, Joe. Okay? This one here. All right? So again, we're just going to put it in our calculator, hit our y equals. Just clear it out. So x to the 4 minus 4x to the 3rd squared. All right. Again, making sure I typed it in right. Okay. And then I watch the graph. Looks like it bounced there. Looks like a 2. Is that right? You guys that did it? Okay. Does it work all 4 times?
No.
Only works 2 times? Okay. So again, just checking to make sure, looking at my table. Yeah, 2 is the correct 0 there. And it's got to work at least twice multiplicity, right? Because it bounced. When it bounces, it's got even multiplicity. So this could be a 2 or a 4 times that it works. 4, 3, 2. I don't have to add any zeros. Make sure you check that. Two times 9 negative 4. What's that? 49. 2 times 49 is 96. That doesn't seem right. Oh, because it isn't. It's 98, right?
Yeah.
So what's that? 98, right?
Yeah.
Negative 98. So it's negative 196. So again, we knew that was going to happen, right? Because the calculator told us 2 works. And since it bounces, we know it works at least another time. 2 times 1 is 2, is 0. 2 times 0 is 0, 49. 2 times 49 is 98. and then 0. If I try to do it a third time, you'll see that it doesn't work. Okay? So it's got 2 real zeros. This has a multiplicity of 2. Okay? But there's going to be 2 imaginary. All right? So remember, it started out, this was x to the 4th in the beginning. So that one's x cubed. This is x squared. Plus 0x plus 49 equals 0. That's the problem now. Do I need to worry about that 0x in the middle, Owen? No. So I can just write x squared plus 49 equals 0. This one, I don't have to use the quadratic formula. When the b is 0, I can just get the x squared alone by subtracting the 49 and then doing what to both sides? What can I do to both sides to finish? Square root it, right? So when the b gets 0 like this, and this happens often, not a whole lot, but it does that more than just a little bit, all right? You get that 0 there. It makes it a lot quicker. You don't have to use the quadratic formula, all right? When I take the square root then of both sides, I get x equals, remember, when I do this step, and we're solving a quadratic like this, we got the plus or minus. So there's the other 2 answers. And what's the square root of negative 49? 7i, right? So we got a 2 that works twice, right, Garrett? And then we got positive 7i and negative 7i. That's my 4 zeros. Okay? Is this starting to make more sense? Okay? Last week we kind of went through this part pretty quick on Wednesday. And then Thursday I showed you the other part. And then I wasn't here Friday to help you out. Okay? So the next one was 8, right?
Yeah.
Do I need to do number 8? Or we got this type down? We okay with this type? I can do it, yeah. I do have the answer. Number 8 is...
I got 1 0 with negative 4.
Double 8, 12. Number 8, negative 4, negative 1/3, 5 plus 2i, and 5 minus 2i. So as you can see 2 of them when you graphed it. One of them was a fraction, and then you had to do quadratic formula to get the 2 imaginary ones. I can do it if you want. Anybody need to see it? Okay. The other 3, 41, 44, and 45. Let's look at 41. We got 3 plus I, 3 minus I. So we got 2 actually got 4 imaginary zeros. 2 plus 5i and 2 minus 5. Garrett, or Gavin, quit messing with those guys. All right. So when we did this, going backwards, giving you the zeros and figuring out the polynomial, okay, how do we always start? Some of you forgot about this. X minus. Some of you just put 3 plus I and 3 minus I and tried to FOIL it and got just a number, okay? Which is, when you FOIL those, that's what you should get, just a number. But you need a polynomial, you need some x's in there, okay? So you have to put x minus 3 plus I, x minus 3 minus I, x minus 2 plus 5i, and x minus 2 minus 5i. You always got to put the x minus in the front. Those are the factors. Now, okay? And then we FOIL, okay? And you need to do these 2 together because those are complex conjugates. And you need to do these 2 together. And that way, all your i's will cancel out so that the second part here, once I get those two answers, then I can multiply those two together and finish it up, okay? So remember, you gotta go x times all three of those. So x times x times -3, and x times -I. Okay, and that's the first thing. There's gonna be 9 of them. Then I'm gonna take -3 times all three. So -3 times the x, -3 times -3, and -3 times -I. So there's the next three. All right, and then I have to take the I times all three of them. So I times x is positive ix, and these will all get canceled. I times -3 is -3i, those get canceled. I times -I is a -I squared. Well, remember, what's I squared equal? -1, right, Drake? So it's minus a -1, which makes it what? Plus 1. So here, you got to remember, there's a 1 in front of that, so that's like plus 1. Okay, so I'm just get confused when it's just -I squared. What do I put there? Okay, well, that's actually a positive 1. Okay, so combining like terms, I got x squared minus 6x, those two, and then 9 plus 1 is 10. Okay, so those first two. Questions? All right, we'll do the same thing for the next one. X times x, x times -2, and x times -5i. So there's those three. -2 times x, -2 times -2, and -2 times -5i. That's the next three. And then 5i times x is positive, so those go away. 5i times -2 is -10i, those go away. All right. And then 5i times -5i is -25i squared, but that's a positive 25, right? Now I combine the like terms to finish it up. So I got x, oops, I went blue. X squared minus 4x, 4 plus 25 is 29. So I have to multiply the black trinomial times the blue one to get my final answer. Okay? Which again, you guys can do. This problem just takes, when you got the imaginary one, it takes a little bit more time because the foiling takes a little longer. All right, so x squared times x squared times -4x, and x squared times 29. So there's those three. And then -6x times x squared is -6x cubed. And -6x times -4x is positive 24x squared. And -6x times 29 is negative 174x. Then I go 10 times all three. So the 10 times the x squared is 10x squared. And the 10 times the -4x is -40x. And 10 times 29 is 290. So now I just combine my like terms to finish up. So I got my x to the fourth, which is what I knew was going to happen because you were given 4 zeros to start, right? So that first term is x to the fourth power. -4 and a -6 is a -10 x cubed. 29 and 24 is 53 and 10, 63. -174, -40 is at -214. plus 290. So if I were to try to graph that, would I see anything? No, we wouldn't see anything, right? So we'd have to use what we call the rational root theorem to try to figure out the zeros and use synthetic division, okay? And, I didn't teach you that or show you that because the calculator usually finds them for us. Right, Sully? Okay. But what you do, when I was a senior in high school and had to do this stuff, I'd have to find all the factors of 290, all the factors of 1, and write fractions out of all of those, and then start using the synthetic division to see which ones work. And keep trying.